In this video, we will go through doing research and writing hypotheses within the scientific method. The second step of the scientific method is doing research. So before we get to that hypothesis, just keep in mind a hypothesis is an educated guess, and before formulating a hypothesis, you must research the topic and use that research to support your reasoning. Research also should be used when explaining and supporting your conclusions. There are many valuable resources that can be used for research. Scientific journal articles, books, videos, internet websites, library databases, and encyclopedias. Ideally, when you're using resources for your research, you're sticking to scientific journal articles or books. And in this case, we can allow internet websites depending on how reputable they are. So generally speaking, wiki anything is not reputable. You want to try to stick to websites that are .gov, .org, or .edu websites. If you are unsure how to use any of the above materials or have questions about where to find information about a certain topic, the White Oaks Library is a great resource. Librarians can point you in the right direction and assist you in collecting information and recording your sources. Some important things to remember when conducting research. Make sure the material is up to date. So science is constantly changing with new discoveries every day. Some books may contain old material. Make sure to check the publication date. Basically, if you're doing research on, let's say, climate change, you don't want a book about, or you don't want necessarily material written in like the 1960s, let's say. That may not be a good starting off point. You may want to draw on some of that material, but it's not going to form the foundation of your research. Make sure the material is from a reliable source, and that source is accurate, as I mentioned before. Wikipedia, while easy to use, is not always correct. It is not. It is an open source or open website where anybody can contribute whatever they want. So I could go in and write about poetry, which I know nothing about, but could act like an expert on it. So like there is no kind of there is no review process for the information that is provided. While there are editors with Wikipedia, it might be a while before they get to that information. So that I have provided, that's not accurate. So Wikipedia, not a good source. You want to look at the domain name, like I said, and some good choices are ones ending in edu, so it's coming from an educational institution, .gov from a government institution, org, which is nonprofit. .ca used to be okay. Now most websites, if they do have a .ca at the end, they may or may not be the most reliable. Use discretion. As you read through the material, are there spelling mistakes? Are there grammatical errors? Do things not just generally seem right based on what you know? So use some discretion and some critical thinking as you're going through various sources. And so, as Sir Isaac Newton once famously said, the problem with information on the internet is that you can never be sure of its validity. Wise words from a man who lived many centuries ago. Make sure you understand the information you are getting from the website. Could you explain it if you were questioned further? So do not just copy and paste from the website. Make sure that you understand what you are including. All research must be referenced and cited in your own words. Any failure to comply with this will result in serious consequences. So if you cut and paste a passage and put in a reference, it is still considered plagiarism. Research must be rewritten in your own words. And here is just a blurb about academic dishonesty. So academic dishonesty is basically when we're talking about plagiarism here. Plagiarism is the action of taking and using one's own words or using one's own the thoughts or writings, inventions of another and passing them off as your own. Plagiarism is the idea. Plagiarism of ideas also exists. So if a student takes and uses an idea without giving proper reference, for example, to note the author or source of the information, including the internet. So plagiarism is a form of cheating, and any cheating in any form is unacceptable. So some items to use when keeping track of references, just don't keep the tab open on the website and hope that's suitable. Computers crash, web browsers close, things happen. So keep a log of it, whether it's digital or by hand. And information that you want to make sure that you note about any particular reference, would include within a book. You want to note the author, the title of the book, the city of publication, the publisher, the year of publication. Important things to take away and use in your referencing. From an article, a scientific article, you'd want to note the author or authors, the title of the article, the journal name, the volume number, and the year of publication, and oftentimes the page numbers, depending on the referencing style. From websites, you want to include authors, if they are available, the title of the document, the upload date, the sponsoring organization if available, the date accessed, and the URL address. You should always have the date accessed and the URL address. Generally speaking, if a website does not have an author, I would recommend not using it. You should know who has written about that piece of information, or who has provided that information. So once you've done your research, you can then use that to form a hypothesis. Now, the first step of the scientific method is to create a good question. The second step requires you to gather information. The third step of the scientific method attempts to determine what the answer is. It is called a hypothesis or an educated guess because it should be a reasonable answer. It is possible to have more than one answer for any given problem. So in the first example, we can look at why do people breed dangerous dogs like pit bulls, and come up with an educated guess as to why. In the second example, like why do some people get skin cancer while others do not? We would come up with an educated guess as to why. So look at the following examples, come up with your own hypotheses, and we can discuss at a later date. When writing a hypothesis, there is a particular format that you want to use. You want to use what is called the if, then, because format. So a hypothesis is a possible explanation or a prediction for observed cause-effect relationship. Often it is worded if, then, because, or as, then, because. The if part of the statement is the cause variable, the independent variable, and the then part of the statement is the effect variable, the dependent variable. And we'll talk about what an independent variable and a dependent variable are later on. So here, we have some examples of written hypotheses. So here we have if more heat energy is added to the water, then the water will come to a boil faster because the water particles will be moving faster. So here is the if part. So if we change the heat energy, so the independent variable is the thing that we are going to change in our experiment. So if more heat energy is added, then the water will come to a boil faster. So this is the thing that we are measuring. So this is our dependent variable here, how fast the water will boil. And then the because part of the statement here offers up the justification for why we think more heat energy will cause water to boil faster. So in the following examples, you can take some time and come up with a hypothesis for the following questions. So why do some children get more cavities than others? Why do people who smoke put more salt on their food? Why do houseplants grow towards the window? Why does water evaporate faster when its surface area is increased? Why do some students get high marks in school? So come up with some hypotheses using the if, then, because format, and we will go through those at a later time. So in writing those hypotheses, we'll use this idea of variables. So with variables, this is helpful in coming up with an experimental design. So in order to complete this step, you need to understand how to identify variables in your hypothesis, as mentioned on the previous page. So most experiments in science are correlational studies, so experiments which look at the relationship between two variables. And what do we mean by a variable? Well, a variable is something that can change, so something that you can vary, something that you can manipulate or change intentionally. So there are three types of variables that we have to consider within our scientific experiment. There is what's called the independent variable, or abbreviated IV. This is referred to as the cause variable or the manipulated variable. What it can be referred to, we will just generally refer to it as the independent variable, with the understanding that it is the manipulated variable. So it is the variable in which the experimenter deliberately changes. So it is the thing that we are going to change in our experiment because we want to know how it is going to affect something else. The next type of variable is the dependent variable. So this is abbreviated as DV and is referred to as the effect variable or the responding variable. This is the variable which the experimenter measures. So this is the thing that is going to be affected in our experiment, in which we will measure how it changes. So for example, if we want to know how volume of water affects plant growth, our independent variable would be different volumes of water that we would add to the plants, and then our dependent variable would be the height of those plants that we measure as the experiment goes along. In our experiments, there will only ever be one independent variable and one dependent variable. So you do not have multiple independent variables. You do not change multiple things. You only change one thing in your experiment, and you only measure one effect. The third type of variable are control variables, which are abbreviated as CV. And these are variables that we do not change in the experiment, but they could change, but we do not allow them to. So these are things like, if we're going back to our example about volume of water and plant growth, other variables that could change would be like the length of time that a plant receives sunlight, the amount of fertilizer that is added, things like that. These are other things that could change, that might have an effect on plant growth, but we hold them constant, or we do not change them. So the thing to think about with control variables is you want to ask yourself the question, so what does a scientist have to do in order for this to be a fair test? So knowing what you know about independent variables and dependent variables, you can go back to these previous questions in which you may have worked on and modify them so that you work to identify the independent variable, the dependent variable, and then set up your hypotheses using the if, then, because statement incorporating those independent and dependent variables. So if you need as well a bit of practice identifying variables, so here we'll read the question and then beside each variable listed under the question, write control variable for something that should be controlled, DV for the dependent variable, or IV for the independent variable. So in the following question, how are the students' grade on a test affected by the amount of television watched? So here is a list of variables. Determine which one would be the independent variable, which one would be the dependent variable, and which other ones would be the control variables. Remember, you can only have one independent variable, one dependent variable, everything else would be a control variable. And then repeat the same with the following questions. So what type of surface material best reduces friction on a skateboard wheel? In the following questions, which we'll work through at a later time, you'll read the following scenario and then answer the following questions. So there's several scenarios here. Try one out if you want to. And then the following picture just shows a way in which you could plan out your experiment, incorporating things like the hypothesis that you're going to come up with and your independent variables and dependent variables as well. And we'll go through this particular diagram at a later point in time. Talking about how we can use such a diagram to help design our experiment. But basically, it's referred to as a fishbone diagram. Here we have our independent variable, and then we're going to talk about we can determine, like, for our independent variable, what instrument we will use to change that independent variable, what units we will use to measure it, and then same with the dependent variable. And so that is the end of this video, looking at hypotheses and variables.